DC circuits part 2. In this section, we'll be covering mainly the dangers of electricity as well as the wirings in a 3-pin plug. Okay, so these are the learning outcomes. We'll be covering the first point, second point, and third point. Okay, the subsequent last 3 points we'll be covering in the next part of the DC circuit videos. Okay, so what are electrical hazards? Okay, electricity can be dangerous. So there are two main dangers of electricity because electricity can cause either an electric shock or a fire. So these are the two main electrical hazards. Okay, so how do we take precautions to protect ourselves? Let us look at situations that might give rise to either an electric shock or fire. There are 3 situations that can give rise to either electric shock or electric fire. Okay, the 3 situations are usually caused by damaged insulation, overheating of cables, as well as damp conditions. So you can read over here and you can think about the answers to this. Is it safe to touch exposed wire? So there is this girl over here who says, hey, the wires are exposed, but it's still safe, right? Only the high voltage wire is dangerous. The other wires are still safe to touch. And then the guy over here says, I think it is safe. Electric charge only flows inside the wire like water in a pipe. It does not flow on the outside of the wire. And say, no, exposed wires are dangerous. So you may think about the answers to all these questions that the cartoon has. Okay, so we go on into the first scenario that might cause electrical hazards, which is either a fire or electric shock. Okay, the first one is damaged insulation. We know that all our wires are usually covered with insulating materials to prevent electric shock. It prevents anyone from touching the bare wires. But insulation can become damaged with age and prolonged use. There is wear and tear, and therefore the insulation gets damaged. And once the insulation gets damaged, your wires are exposed, like as in shown in this picture. So exposed wires are dangerous because if you happen to touch one of them, which is called the live wire that has a high voltage, okay, you will get an electric shock because with the high voltage, current can flow through your body and down to the ground, and that will cause you an electric shock. Okay, so exposed wires can cause electric shock. The next scenario is about overheating of cables. Overheating of cables is when there is too much heat being generated in the cables. And overheating usually occurs when there is too much current flowing through the wires. Okay, and it happens when there is overloading. Okay, or it can also happen whenever there is a short circuit. And whenever there's a short circuit, there is a large amount of current flowing through the circuit. Or it can also happen when you use appliances with the wrong type of wires. Okay, some appliances need thicker wires because thicker wires have lower resistance and therefore it doesn't produce much heating effects. But if you use thin wires for electrical appliances that uses a lot of electricity, then thin wires have higher resistance. A lot of heat will be generated in the cables as well. Okay, so overloading is when you have too many plugs plugged into a single socket, like when you're using a multi-plug, and then you switch on all the appliances. When all the appliances are being switched on at the same time, it draws out a large amount of current from the main socket. And when the current exceeds what the main sockets can provide, okay, we say that there is overloading. Okay, and when there is overloading, what happens is a large current flows. Large current flows, it generates a lot of heat, and this will cause an electric fire. It doesn't cause an electric shock, but it causes an electric fire. Okay, and then lastly, it's about dam conditions. We know that electricity and water doesn't mix. Okay, when there is water present, okay, it is likely to cause an electric shock because our normal body has a certain amount of resistance. When we touch an appliances, because of the amount of resistance in our body, not much current flows through our body. But when your body is wet, you touch an electrical appliances with wet hands. So your body is wet. Okay, the water will lower the resistance of our human body greatly. So whenever there is water, water is a good conductor of electricity. So it lowers the resistance of our body, which allows a large amount of current to flow through our body. And therefore, it might cause an electric shock. So we need to keep our hands dry to prevent ourselves from getting an electric shock. Another possible way is by wearing rubber shoes, okay? Because by wearing rubber shoes, we stop the path from for the current to flow through our body down to the ground because of the rubber shoe, which is an insulator. So it forms an open circuit, okay? It cuts off the closed path to the ground. So electricity will not flow through your body and you will be safe. You will not get an electric shock. So overall, let's do a very, very quick recap about dangers of electricity. There are two main dangers or two main electrical hazards, which is fire and electric shock. And they're mainly caused by three situations. So the first situation is when you have the damaged insulation, the wires gets exposed. If you touch the live wire or the wire with the higher voltage, you get an electric shock. The second scenario is caused by overheating of cables. It's usually caused by large current flowing inside the wires. So the wires becomes very hot and the wires may melt and may even start an electric fire. And the last one is dam conditions, because water provides a conducting path for the current to flow down to the ground, so it causes a person to get an electric shock. Okay, so let's go on into the next part. Next part, we'll talk about the wirings in the 3-pin plug, okay, which is what we commonly use in our household. Okay, these colors is only unique to Singapore. When you go to other countries, 3-pin plug, the colors of the wires are different, okay, but these wires are just for easy recognitions, okay, but they are not important. But in Singapore, we just label it according to these colors. Okay, so there are usually 3 wires in a 3-pin plug or in any cables that you find at your home. So the first color is brown in color. Okay, it's called your live wire. So your live wire is the one that is dangerous. It has a high voltage. It is connected to your power sockets, which has a voltage of 240 volts in Singapore. So it is the wire that brings electricity to the appliances. Okay, and it is also the wire, because it's the dangerous wire, it's also the wire where the circuit breaker, the fuse, and the switch are always fixed onto this wire, the live wire, the dangerous wire. Okay, the next 2 wires are not dangerous because the next 2 wires, the blue and the yellow and green wires, blue wire is called the neutral wire, is at a 0 volts. Okay, so that it doesn't have any voltage. So even if you touch it, nothing is going to happen to you because it has 0 volts. There's no energy that pushes the charge to go through your body. Okay, so what does the neutral wire do? Okay, the neutral wire simply provides a returning path. Okay, so you have a live wire that brings electricity to the appliances, and then the electricity needs to go back to the main socket. Okay, so it goes back to the main socket via the neutral wire, and all the energy is already used up by the appliances. So there's 0 volts in the neutral wire. Okay, and then lastly, the earth wire is a safety wires. Okay, we do not necessarily need the earth wire. That's why there's some appliances with just 2-pin plug. So for appliances with 2-pin plug, I just have the live wire that brings electricity to the appliances and neutral wire that brings electricity back to the main socket. I don't even need the earth wire. So the earth wire is coded in yellow and green. Okay, again, it's 0 volts. It's very special because it has very low resistance. Okay, it's just a copper wire, very, very low resistance. And where is the earth wire connected to? One end is connected to the ground in the socket, wall socket, and the other end is connected to the metal casing of the appliances, We usually only have earth wire if there is any metal parts on the appliances. So this earth wire, the other end will be connected to the metal part of the earth wire, the metal part of the appliances. Okay, so let's take a look at how they are being wired in a 3-pin plug. In a 3-pin plug, okay, you have the topmost pin over here. Okay, it's the longest pin, is the earth wire, because safety first. Okay, when we plug the 3-pin plug into the wall socket, we want to ensure that the appliances is first in contact with the ground. Okay, the metal casing, the other end of this wire goes to the metal casing. This metal casing is being earthed first. The other end of this earth pin goes to the ground. We ensure that the appliances is earthed before we connect it with the power source from the live and the neutral wire. Okay, so that's why the earth pin is always longer. So this is the earth terminal. Okay, and then on this side, we have the blue wire is the neutral terminal. How do I know it's the neutral terminal? Because there is the presence of this thing over here, which is called the fuse. The fuse is always connected to the live terminal. Okay, fuse is a safety device. All safety devices are always fitted onto the live wire because the live wire is the dangerous wire with the high voltage. So this is the neutral terminal, and this is my live terminal with the fuse over here. Okay, and then I have a cable grip that grips this cable. The purpose of the cable grip is to ensure that with any tugging of the cables, for example, you trip over 3-pin plug cables, or someone is pulling on the cable, it ensures this cable grip ensures that all these wires remains connected to the terminals. Okay, instead of being pulled out of the terminals and then the wire can't loose. Because when the wire comes loose, it becomes an electrical hazard as well. It may cause a short circuit. Okay, so I don't want the wires to come loose. That's why I have a cable grip over here. Okay, so this is how it looks like. It is the 3-pin plug with the earth pin being the longest, and the earth pin is being plugged into the wall socket. So this is your wall sockets. Okay, the earth pin is here, and then the live pin will go into here, and the neutral pin will go into here. So the earth pin at this part in your wall socket, the other end goes down to the ground, and this live pin over here, okay, the other end is the one that comes out, that brings electricity at high voltage. 240 volts is coming out of this pin over here. Okay, and your neutral wire has 0. It simply brings the electricity back to the power source. Okay, so let's take a look at how the 3-pin plug is being wired to an electrical appliances. These two diagrams is actually the same. So I have the earth pin, which is the most easily recognizable. It's always at the top. The longest pin is yellow and green. So the earth wire, one end is connected to the wall socket, to the ground. And then the other end, you can take a look, is connected to the metal casing of the appliances. So this part is the metal part of the kettle. Okay, then my heating element, my live wire is connected to the fuse. Okay, so my live pin is here. It carries out 240 volts from the wall socket. And the 240 volts will go through this fuse and then go through this live wire, brown in color. And then the switch, okay, this switch is usually the switch on the electrical appliances itself. Okay, so this switch is also connected to the live wire, which is the dangerous wire. We'll talk about why later on. Okay, so once you close the switch, electric current will flow out from this live terminal, live pin 240 volts, 240 volts, 240 volts, and then it will go through this heating element to heat up the water. Okay, so all the 240 volts will be used up by these heating elements, and after that, after this 240 volts is being used up by this heating element, I will have 0 volts to go back. Okay, so the current will still needs to go back to form a closed path. So the current goes back via this neutral wire, and all the voltage will be used up by the heating element. So the neutral wire, this blue wire, has 0 volts. Okay, it goes back to the pin. So this is exactly the same as this live wire with fuse and a switch. Goes to the heating element, back by the neutral wire, 0 volts, and then the earth wire, this end is connected to the ground, earth thing, and then the other end is connected to the metal casing. Okay, so just to take note, if the appliances is functioning normally, all the current will flow through via the live wire and then go through the heating element, and the same current must flow back to the circuit via the neutral wire. So the current in the live must be equals to the current in the neutral wire. There is no current in the earth wire when under normal working conditions. Okay, so that's it for the second part of DC circuit. I mean for practical electricity.